Okay, freshmen, good morning. Today is Friday, April 3rd. It is our sixth day of genetics. This is our last class before your spring break. Today's class is pretty straightforward. We just need to wrap up grading the packet. It was brought to my attention that I did not post the answers to the second half of page 4, so I'll go ahead and do that now. And then after we grade the packet, your assignment is a activity that's attached called Who Gets the Money? It's sort of like a murder mystery type scavenger hunt, and using what you know about all the types of Punnett squares, you can try to solve the rightful heir to a big fortune of money from a old couple who doesn't know who their long lost son or daughter is. So using what you know about the old couple's genetics, you should be able to solve the answer to who gets the money. The biggest assignment, or the most important thing for today, however, is to upload your work to Edmodo. Talking to other teachers, and it sounds like most teachers are having students upload work, which is basically proof that you are following along. It'll go in as gradebook, but will not be graded. It'll be checked for like does not count. But the biggest thing is I just want to see of my three classes, how many of you are following along, how many of you are getting behind, how many of you are keeping up, etc. And then last thing is enjoy your spring break, question mark. I don't think anyone's doing anything too exciting for spring break. You're probably staying inside, staying with your family, not seeing your friends, not going to movies, not going to baseball games or the beach. So it's a bummer, but again, guys, the most important thing is that you're staying safe. Okay, go ahead and get out those packets and open up to the second half of page 4. For sex-linked trait, question 4, a homozygous recessive female is going to have a two small c's. Homozygous recessive meaning both of her X chromosomes have the recessive C. A colorblind male is also going to have a recessive trait for colorblindness, but remember he only has one recessive trait because the male only has one X chromosome. So when you do the Punnett square, remember that we need to cross both male and female. So the male might give his X chromosome 50% chance, might give its Y chromosome 50% chance. This dictates if the couple has a boy 50% chance or girl 50% chance. And as I mentioned in the video last class, gender is determined by the male. And the female is going to pass on one of her X chromosomes. Doesn't matter which one because both X chromosome has the colorblind allele because she is homozygous recessive. So genotype ratio is 2 to 2, either 2 x little c, or 2 x little c y. Or phenotype ratio is probably a little easier to say. It's either going to be a colorblind female or a colorblind male. It's a 2 to 2 ratio, 50-50 chance. Remember, half a point for this, half a point for that. Question 5, carrier female is going to be X dominant C, X recessive C, with a normal male, which is X dominant C, Y. We do the cross, and we see that there's a 25% chance that they have a homozygous dominant female. 25% they have a heterozygous female, which remember with diseases, we call that a carrier, someone who's carrying a recessive trait but not showing that recessive trait. 25% chance they have a male who is normal vision, 25% chance they have a male who is colorblind. So our genotype ratio is 11011. And again, as long as you label it, the only genotype that we would not have is homozygous recessive C for a female. X little c, X little c. Phenotype ratio 211, because realize no matter what female they have, if it's homozygous dominant or heterozygous, that female is considered normal vision. A carrier would not show up in a phenotype. A carrier would only show up in the genotype. Okay, moving on to page 6. Those of you that were in the Zoom on Wednesday, you can fast forward because we already went over the next two answers. But what I mentioned for dihybrid crosses is the most important thing is this right here. If you get this genotype wrong, then you really have no chance to do the dihybrid correctly. So homozygous Bent-Pinky is going to be homozygous dominant for B. Heterozygous free earlobe is going to be dominant and recessive allele. Homozygous straight pinky and homozygous attached earlobe is going to be homozygous recessive. Good question in the Zoom. Does it matter which trait you do first? No, you could do FFBB or BBFF. It doesn't matter because each trait is being crossed individually. We FOIL to get our 4-parent allele possibilities. We do the cross. Remember my system where I said I think it's easiest to count up like this, like 1, 2, 3, and then you get all the genotype ratio, and then as you keep counting for phenotype, 1, 2, 3, and then we should be able to count 15 boxes each way, or sorry, 16 boxes each way. If your answer does not add up to 16, it means you made a mistake somewhere. Anyways, genotype ratio is 8:8. Phenotype ratio is also 8:8 because in this instance, the difference in the genotype is heterozygous for bent pinky or homozygous recessive for straight pinky, meaning the difference in that genotype is also a difference in phenotype. Again, actually, you know what? Let's make this 2 points. 1 point for genotype, 1 point for phenotype because these questions take a lot of work. Next question. Person 1 genotype is heterozygous. Person 2 genotype, heterozygous. I actually didn't need to do the cross because this is like, it's kind of taught commonly in upper level bio classes that when you dihybrid cross 2 heterozygous individuals, you get a 9:3:1 ratio. 9 will be dominant in terms of traits. 3 will be dominant recessive. 3 will be recessive dominant, and 1 will be recessive. If you got 9:3:1, it means you did a good job. If you got this part off by a little bit, I wouldn't worry too much about it. It's pretty hard to count 1, 2, 3, 4, 5, 6, 7, 8, 9 different genotypes and keep the numbers straight. So again, I wouldn't beat yourself up if you got that one wrong. But if you got the phenotype right, 1 point. If you got this right or say off by 1, give yourself a point for genotype as well. All right, now we get into the more difficult questions. The dihybrid cross between Gloria and Jay. Based on the reading, we know the genotypes for Gloria and Jay. Gloria, this is worth 2 points. Gloria is heterozygous A, homozygous recessive T. Jay is homozygous dominant A, heterozygous T. How did we know that Gloria was heterozygous here and Jay is heterozygous here? Because of their parents. We were told in the parents that Gloria's mom, I can't remember if it was Gloria's dad or Gloria's mom, but one of them was homozygous recessive. We know that Gloria has a dominant A based on the reading, but if one of her parents is recessive, then she must be heterozygous. Same with Jay. One of his parents was recessive for T. So we know that he's got to be heterozygous for T. We solved the dihybrid cross. This is worth 1 point. Phenotype ratio, 8:8. All right, so if you filled this out, give yourself half a point. If you got this right, give yourself another half point. Oh, sorry. That whole Punnett square was just worth 1 point. The phenotype-genotype ratios is worth 1 point each. Genotype 4444, phenotype 88. And then lastly, this is the hardest question. Tell me everything you definitively know about both Jay and Gloria's parents. This symbol means mom. I'm sorry, this symbol means woman. This symbol means man. So woman pointing to Gloria. This is Gloria's grandma. I'm sorry, Gloria's mom. All we know is that she had a dominant A and a recessive T. We don't know what goes here. We also don't know what goes here. Gloria's dad, we know a lot more about. We know he's homozygous recessive for A, heterozygous for T. Jay's mom has at least one dominant A allele because we know that Jay got both dominant A alleles. We also know she's homozygous recessive for T. And then Jay's dad, all we know is that he's got one dominant A and one dominant T allele. Because again, could Jay's dad be this? Sure, he could, but he could also be this. And the question is, what do we definitively know? And nothing tells us if Jay's dad is homozygous dominant or heterozygous for either trait. So all we know is he has at least one dominant A, one dominant T. This is definitely the hardest question. I'm expecting a lot of people to get some wrong answers here, but the more important part is after you look at these answers, look back at the instructions and see if it makes more sense to you looking at it a second time around. 2-point question, so that means each parent is worth half a point. But again, if you had more information, like if you said Jay's dad was definitely this or definitely that, that means you got it wrong because that does not answer the question. All we know is this. Okay, that's it for checking our homework. So again, the assignment for today, who gets the money, is posted right below this video. You can print it out and put your work on the sheets, or you can just make notes on scrap paper, whatever's easiest for you. And then the most important thing today, especially for like due diligence, for me to check over spring break, who's been following along, who has fallen off the face of the earth, what students do I need to contact, what students are keeping up for the most part. I would like you to upload all the work you've done on this genetics unit, which is pages 1 through 6 of the packet. It should be graded. And then your work and your final answer for who gets the money. We'll finish the packet and learn about pedigrees after spring break. That is it. I'm signing off for the last time in 10 days. I'll see you guys on April 14th. It'll be a long spring break for me, just kind of being stuck at home, keeping my family safe, making sure that things are going okay. So hopefully for you guys, things are, again, I don't want to say have a great spring break, but try to manage for this spring break. Try to keep in touch with your friends, read a book, go out in the backyard, staying safe, keeping social distancing, all that wonderful stuff. Okay, bye guys.